All right, so let's take everything that we've done this year and let's kind of put it all together and look at it in the terms of solutions. So we have already learned that ionic compounds conduct electricity when in their aqueous form, a solution. All right, so solutions that conduct electricity are called electrolytes. And these solutes are going to be ionic compounds or salts, all right, because we know that ionic compounds conduct electricity when in their solution form, so we call these electrolytes. They can be a strong or a weak electrolyte. Strong electrolytes are going to easily conduct electricity. All right, and this example, all right, could be something like NaCl, sodium chloride. When I put sodium chloride in water, it will dissolve into 100% sodium ions and 100% chloride ions. So we call that 100% dissociation. It completely makes all ions. A weak electrolyte barely conducts any electricity. It'll conduct a little bit, but not a whole lot. So in this case, solutes are able to exist as both ions and molecules. So an example of this would be acetic acid. This is vinegar. So here's our formula for acetic acid, which is vinegar, HC2H3O2. Now, when I put this in water, vinegar is a weak acid. So what it does is it produces it breaks apart into its ions partially. All right, so we have this hydrogen ion, H+, and we have some acetate ions. Okay? But the majority of the acetic acid actually remains intact as acetic acid. So we get some ions, but the majority of it remains a molecule. Okay, the majority of it remains a molecule. So we say that it has partial ionization. A solution that does not conduct electricity is called a non-electrolyte. And these are going to be molecules because if you remember, we said that covalent compounds do not conduct electricity and covalent compounds are molecules. So then an example of this would be sugar and water. And what you end up with is just a solution of sugar that's been dissolved in the water. Okay, but we don't have any ions in order for it to conduct electricity. All right, let's look at colligative properties. So these are properties of a solution, and they are going to depend only on the solute concentration. So solute dissolves in solvent. So they depend on the concentration of what's being dissolved. And this is going to be the concept behind making ice cream. So ice cream is made and able to be made due to colligative properties. So a freezing point depression is a solute that lowers the freezing point of the solvent. And this is why we salt roads during snowstorms. All right, the salt, these ionic compounds that we put on, will mix with the snow and lower the freezing point at which that snow freezes. All right, so snow typically freezes at 0 degrees Celsius, but when we add salt, that temperature drops below 0, so it has to get colder for the snow to actually freeze. So Let's look at a picture of this. When our solvent is absolutely pure, its individual particles can interact without any obstruction. So that's this first one. Okay? So there's nothing here to obstruct the interaction of these water molecules. But when I add an impurity such as a salt to it, they disturb the stabilization of this interaction. And the big fancy term for an interaction of these molecules are intermolecular bonds. And when you take chemistry next year, you are going to learn all about the different types of intermolecular forces. All right? So it disturbs this interaction. See right here we have salt, all right, or a salt ion, an ion in between the two water particles. So the temperature at which it has to get in order for there to become a bond back between those two water molecules is much lower. Boiling point elevation. This is when solutes raise the boiling point. So there's not really a blank here. Solutes raise the boiling point of a solvent. So for example, if I add salt to water, it is used in the sugar refinery process to ensure that sugar crystallizes properly. So when you go to the store and you get some sugar in a bag and you take it home, you'll notice it's got these nice white crystals. All right, we get that through the process of using the concept of boiling point elevation. So essentially what happens here in a pure solvent, all right, molecules at the surface, when they get enough kinetic energy, because when we boil something, we add heat, heat increases kinetic energy, they are able to escape from the liquid form into the gas form. All right, gases have more kinetic energy right here at the surface, but they're able to do this freely. When I add a solute, these solute particles, again, get in the way. All right, so these solute particles are now in the way. This solvent may want to have enough kinetic energy in order to escape out into the atmosphere, but it's being blocked by the solute. All right, so the temperature at which we have to boil this is going to be higher. This solvent is going to need more kinetic energy to get past that solute than when no solute is present.